this video, I'll explain the algorithm to make a Bullseye matrix. The algorithm will be in such a way that our input will be just a single number and the algorithm will give Bullseye matrix as output. For example, if you do n is 3 as input, then this will be the algorithm will give this as output. For n is equals to 5, this will be your output. For n is equals to 7, this will be your output. Well, you must have understood by now, if you watched the previous videos in this series, that Matlab provides a good control over matrix. You can update a single element, an entire row, or an entire column. So, similar to the back and forth matrix code, which was the previous video, you will find the patterns hidden in these matrices. You can see there is a clear pattern that the innermost element is 1, and then 2, and then 3. So these kind of boundaries are there. So all we have to do is to come up with the generalized mathematical expressions which can represent all the patterns so that we can feed these into for loops. So before starting, let's understand one thing, that there is never a single approach to build these algorithms. There can be many possible ways. Well, not that many, Dr. Strange. It depends on one's thought process and imagination. Here I'm presenting you my approach. You can make it better with your own method. So let me explain you with the example for n equals to 5 how I proceeded. In the first step, I uh, calculated the indices for the innermost element, which you can see clearly that n plus 1 by 2, n is 5, so n plus 1 by 2 is 3 and 3, so the a33 will be the innermost element. So then I can update it in if I have the indices. Then after that I am going for the outer boundary just after the innermost boundary. So there you can see clearly that first you have to update two rows, and then these rows, if this is the ith row and ith jth column, then you can see that if you will go for I minus 1 row, then you will have the upper row, and for I plus 1 row, the lower row. So yeah, these elements will also be updated, the 3 3 here and the 3 3 here in this row, but anyway this will be taken care of. I'll show you in the coding how. And then after that I am going for the columns. So basically I'm using these four equations to update the just outer boundary after one, and then the similar equations will be used to update the outermost boundary by using I minus, instead of I minus 1 we'll use I minus 2. So let me show you how you can code this. Okay, so let me show you how you can code for the Bullseye matrix. And let's start with 3, the simplest, so that you can understand visually that what is going on. So let me first define a matrix with 3 cross 3 dimension. Let me run this. Here you can see that we have created a matrix. Now, as I told you, that first in my algorithm, initially I am updating the innermost element, and here the formula for that I also mentioned, which was this n plus 1 by 2. So you can see clearly that n is 3 here, so sorry, n plus 1 will be 4, by 2 will be 2. So this element is 2 cross 2, so we will update this with 1. Let me show you. So here this is basically nothing, 1 comma 1, so we are, sorry, 2 comma 2, so we are updating the 2 comma 2 element by 1. So this is normal element modification in a matrix. And if you go for row or column, let me show you that also. So if I write 1, as we have to update the first row and the third row. So first row all the columns. If I will just write 2 and then a third row, all the columns also 2. So here you will see 2 in the first row, 2 in the third row. Now similarly you can update all the columns also. So all the rows of first column must be 2 and all the rows of third column must also be 2. So here you can see we have created a Bullseye matrix, but you can see that this is not generalized code. If we will proceed like this, we have to for larger dimensions we have to continue doing this stuff. Okay, so let me show you how you can make it generalized. By now, if you are watching the videos, you must have a clear idea that we can make anything generalized by having an expression and putting this expression into loops. -1. So why am I doing here -1 from 1 to only this element? Because just see for n equals to 3 and you will get idea. For n equals to 3, this particular thing will be 2. So when you will be subtracting 1 from 2, it will be just 1. Why is that? Because from the centermost element, we have to update only the one column in left side, one column in right side, one row in the upward direction, one row in the downward direction. If it will be 5, then you can see that n plus 1 by 2 minus 1 will be 3. So it will be 3 minus 1, which is 2. So we have to move from 1 to 2. Okay, so let me make these things also generalize. Okay, let me first mention the indices. The left hand side, plus 1 by 2 minus I. In the right hand side also, n plus 1 by 2 plus I. So these will be the indices of left hand side modification and upward modification, and these will be the indices for right hand side modification and downward modification. You can see that we are doing I plus 1 here. So this is the indices of the centermost element, and if you'll add, when the loop will have I is equals to 1, then we will be updating this element and this element, and will when it will be plus, so right and lower. Okay, so let me just, what number we have to modify there is I plus 1. You can see that when this loop will be running for first time, we will be updating the just outer boundary of 1. So there the element must be 2. So if we'll do I plus 1, then this will be modified by 2, and when this loop will run for second time I equals to 2, the outermost boundary will get the number of 2 plus 1, that is 3. Okay, so let me just left, this will be updated by the number, and right, this will also be updated by number. Here left, this is anyway, yeah, upper row, but we are just writing to reduce the variables here, right? Yeah, so let's end this thing. Okay, so let us see if it's working fine. Yeah, you can see here A is working fine. The answer is, let me just, now you can see this is working. Let's try this for 5. So you can see for 5 also it is working. Okay, let me show you step by step what is happening. for 5. If you see, when the loop is running for first time, it is giving 2 in the outer boundaries, and other these, as we are modifying all the row and columns, so the outermost elements are also getting disturbed, but anyway, with the next iteration it is getting taken care of. Let me show you for 7 also, step by step. Okay, wait, let me just expand this. You can see that the 1 is there because of this command, and the 2 is there because the loop has completed its first iteration, and the outer elements are also modified, but it will be taken care of. Let me show you how. You can see here. So the second outer boundary is getting updated by 3, and there are other elements, not desirable elements in the outermost boundary, but these will also be taken care of here. So yeah, you can think about this and hope it helps. Thank you guys.